Hey everyone, I had a request come in for some additional help on the week 5 critical thinking exercise that's due tomorrow. I wanted to show some problems that are similar to the ones that you might be dealing with in the critical thinking exercise. So I made up these two problems to try to help with that. So you see in the first problem here where it's talking about a survey about meatballs. I was watching Food Network when I made the example, but anyways, here it is. So it says I surveyed 151 people and found that 79 of them preferred Dunkin's meatballs. At the 0.05 significance level, is there enough evidence to support the claim that over 50% of people will prefer the meatballs that I make? So this is going to be a hypothesis test. So a couple of things that we need to define. First off, our alpha in this case is equal to 0.05. That's the significance level. Remember, the question doesn't ask about this, but if you're curious about your confidence level, it's 95%, right? 1 minus the alpha is the confidence level. The next thing you might want to determine is what your null hypothesis is. In our case here, we'd say that our null hypothesis, it's not mu, this is p, is equal to 0.5, and our alternative hypothesis is that p is greater than 0.5. Again, remember the claim says over 50%, so that's greater than. So what we're going to do here is we're going to go to the StatCrunch and we're going to analyze this. So again, if we go to stat, this is a proportion statistic. This is one sample, right? We only grabbed one sample of data. I have the summary. I don't have the individual data. I don't have the responses from everyone. I just have the number of people that said they preferred it. So remember, we'll go back to the examples to find these numbers. So remember, we had 79 people that preferred them out of 151. So 79 people out of 151. Again, we are doing a hypothesis test here. You'll notice that the null hypothesis is already set up for us. It is at 0.5. That's not always the case. I didn't pick that on for this. I just happened to pick this at 0.5. Again, my alternative is that it's greater than, and then from here we're just going to hit compute and we're going to see what happens. So if you want to pause it at this point and look at the analysis from here and see if you can do the interpretation in terms of what the p-value comes out, now is a good time to pause it. Okay, so hopefully you're back from pausing it. We'll go ahead and hit compute here. You'll notice that if we look at our p-value, which is over here, and remember there's two ways to analyze this. You can look at the test statistic, which in this case is a z-statistic, and you can compare that to the critical value, or you can just simply look at the p-value and compare it to your alpha or your critical value, or your significance value. In this case, 0.2845 is our p-value. So if you want to copy that, if you're writing up the analysis here, I would say that we fail to reject based on the p-value of, right, which is greater than my significance value, right, of 0.05, and therefore there is not enough evidence to say there is not enough evidence to say that over 50% of people prefer those meatballs. Okay, so that's just a simple example. Similar to the basketball example, you have two things to do there. Here, obviously, there's only one question. In the basketball example, there's two. But there's a quick example for that one. Let's go down to the second type of example, and this is a goodness of fit. So we're going to run a chi-squared hypothesis test here. So here we see a city assessing their traffic violations during a week. They want to know if they issued the same, oops, that's supposed to say same number of tickets. There we go. Same number of tickets on every day of the week. So during 1 week that they survey or they sample, the city issued the following number of tickets on during 1 week of each. You see the week. Sorry, I can't get my words out. So here are the number of traffic tickets over here given on these specific days. And so what I'm going to do is I'm just going to copy this, and we'll take this over to StatCrunch and we'll clear this out. So I'm just going to put that there. Again, we're running a goodness of fit. So goodness of fit here, this is going to be a chi-squared test. Here our observed column is var2, right? This is what we saw. The expected value are supposed to be equal proportions in my case, right? Remember, the city is seen if they cite the same number of tickets each day. So what we're going to do here, we don't really have to change anything. You can display some other stuff in terms of residuals and things like that. I'm just going to go ahead and hit compute and see what comes out. Again, we're still focusing on the p-value here. So what this is saying down here, this expected stuff, this is what if it was if we were going to cite the same number of tickets every day, then we would expect 28.857 based off the sample size that we have here. We would expect that number of tickets issued each day. In any case, the point of this here is that the p-value is very small, right? It's less than 0.001. Obviously not the same. You can see that in the values that we got here. But again, focusing in on the p-value, again, just to do a write-up here. So down here at the bottom, I would say that I reject the null that all days have the same number of tickets, since, again, the p-value, right? I'm doing it in terms of the p-value, is less than 0.001, right? And that's very small. The alpha in this case you can assume is 0.05. We didn't have one given to us. Again, you can assume that it's 0.05. But again, we would say that we have enough evidence, or there is enough evidence. Excuse my typing here. That there are a different number of tickets issued. There is enough evidence to say that the number of tickets issued each day is different. Or let's do it in the better wording. There is enough evidence to say that the number of tickets issued each day is not the same. That's what we're saying. Sorry, let's not. Again, I want you to be very careful with your interpretation. So we don't want to make conjectures here and say that that one is different than the other. We just want to say what the alternative hypothesis allows us to say, which is that they're not the same. At least one of them is different, is basically what that tells us. Okay, guys, so I hope this helps. Again, I wanted to give you examples of one from each type that you're running into this week in your CTE by request. So again, I hope this helps, but by all means, if you have any questions or anything, just let me know. All right, guys.